Our last talk is by Rob and talking about solving the multi-view problem.
Thank you. Yes, and I will try to do a live demo, which is a huge risk, I think. But the first thing works, which is my laptop is connected to the system. So good afternoon. Yes, it is afternoon in the meantime. So if you have been watching the news recently and streaming news, you will see that both YouTube and Apple have started to roll out what they call multi-view. And if you listened to the talks yesterday, you will have heard at least Michael Raulet talk about more interaction with content, and Ishtiaq Faisal was also alluding to it. So that's what I would like to talk about. Interestingly, in the immersive session, this is a joint paper with my colleague Rai, who cannot be here because today, and I haven't had the news yet, should have become the father of two little boys, new boys. But he's our technical brains behind the solution. And it's interesting that I'm in the technical session in the immersive session, because that's the background of our company, Tiled Media. A lot of people of you here will not have heard of us. We've done some amazing things, so this is the marketing part of my story. We've enabled a World Cup soccer finals in VR. In Beijing Olympics, we've done the Champions League finals. We do 3 Premier League matches each week with Sky. We've recently, like last month, deployed with the 2 largest operators in the world, Jio and China Mobile, doing various VR things. But interestingly, I will not talk about VR, because we got established at the previous hype of VR when people hadn't heard of the metaverse yet. It was still called just VR. But VR isn't growing very fast. And there's still hope. Interestingly, we do get a lot of requests recently, but 2 years ago we decided we needed to do something else. We call this multi-view. So let's take you back to the flat world. And multi-view streaming is a hard problem. Multi-view streaming as in multiple streams on the same flat screen. It's been tried many times, but there's always been limitations. It's sluggish, it's not continuous. People are afraid to switch cameras because they lose track, they lose moments, they lose goals. And when it does work seamlessly, it's a solution that is very hard to scale. And it's always hard to deploy cross-device. So what if you could just do this seamlessly? Have any amount of streams on your screen, switch audio and video independently and without interruption. Be able to add your own story to that of the director. Because let's face it, the director has all of these tools at their disposal, all of these cameras, all these slow motion tools, replays. You don't want to lose that. But sometimes, especially in what's called multi-ball sports, you want to be able to add your own story to that of the director. You have your favorite athlete, your favorite like golf player, for instance, or it's a Formula 1 driver, or it's a MotoGP rider. You want to be able to follow them as well as the director. So, there's a number of approaches. I will briefly touch upon all of them and explain why they fall short, and then see what can be done today. Interestingly, with very much of the same technology that Sachin described in the talk before EMETS, tiled streaming. So let's look at, you can do many encodes. You encode all the permutations of the small videos and the large videos that you want to be able to show on the same screen. And this works if you have a limited amount of streams. But it's very hard to do seamless switching because you need to swap out the whole set of videos. You need to just dump your buffer basically and load a new video in your buffer, and so it's slow, but more importantly, it's extremely unscalable if you want to do this with more than 4 feeds. You get a combinatorial explosion. Imagine if you want to do a large video, an intermediate video, and maybe some small thumbnails. It's impossible. So another approach is to use many decoders. So you solve the problem on the client side, and this also works. It allows for client-side interaction very well. It scales to many users very well as well, because you need only one set of encodes. But unfortunately, it's hard to deploy cross-device because it allows on using a number of different decoders in the device. Audio-video sync between these different decoders is a nightmare. If you want to switch feeds, you will just inevitably get audio drops or skips. And a very hard problem to solve is if you have these independent player instantiations, they will start fighting for ABR bandwidth, which results in a bad experience. So then the last approach is very much akin to what Ahmed was just discussing. It's cloud processing or cloud rendering. This works as well. It optimizes the bandwidth because it streams exactly what you're seeing, which is great. It also allows all possible interaction and layout, which is also great. But it's slightly sluggish, but I think the most important disadvantage is it's extremely hard to scale. Imagine you wanted to do Formula One this way. You have 1 million viewers. You need 1 million WebRTC servers running in the cloud to serve all of your customers that want to use this. So this will never work. So then let's look at what we are proposing and actually implementing and deploying. It's called tiled multiview. So again, we will encode all of the videos, all of the streams, and it can be we've done this with up to 25 streams in the individual streams in a number of different resolutions. And then we retrieve all of them as necessary to the player. So the logic here is at the player side. And I think one of the secrets here, or one of the things that's worth noting very well, is it uses a single hardware decoder. One single hardware decoder, so which makes it deployable cross-device. And then, so you make tiling-enabled HEVC encodes. I'm sure it would work even better with VVC, but VVC isn't nearly as well deployed. HEVC is universally deployed now. It's even starting to come to web browsers, which is amazing. You fetch all of the required feeds from the CDN with simple HTTP requests, which makes it very scalable. You merge them into a single bit stream, you throw the bit stream through the decoder, and then you tease out all of the individual feeds from the decoded frame. This is my slide. We'll go back to the slide. Sorry. I'll just explain it by looking at the slide. So imagine we have like a main video, a couple of pictures at different resolutions, and a set of thumbnails, which are actually video thumbnails. This is what you would see in the UI. Now it's a bit smaller. This is what is streamed. And this is where we get to the heart of the tiling stuff. So the larger image is, in this case, encoded as 9 tiles. The large pip picture-in-picture is encoded as 4 tiles. And the smaller pip is encoded as 1 tile. And the thumbnails, for efficiency reason, are encoded in a bunch of joint composite tiles. So there's like 4 thumbnails in 1 tile. This is what's going through the decoder. So you see it's a 4K decoder, and it has some unused slots. And this is what's encoded. So all of these videos are encoded at a number of different resolutions, at a number of different ABR levels, because it also supports ABR. In order to do this, we need a couple of restraints, but as long as we can control the encoders, it can use fully standardized encoders, and we're working with a couple of third-party encoder vendors right now. Obviously, we built our own system, but use any HEVC coder with just observe that we have the same RDR intervals and GOP structures for all the feeds. A common tile size is used, they don't need to be motion-constrained tile sets like we would use in a VR application, but they would need to have the motion vector constraints to the picture boundaries, not the tile boundaries, but the picture boundaries. And then disable temporal motion vector predictors. And the frame rate is ideally the same, but you could also manage like 30 and 60 frames or a combination of 25 and 50 frames, but ideally the frame rate is the same across all the feeds. And usually from a single production, it is. And then, as I said, throw a couple of thumbnails together as a composite in a single tile. Now, this is an example. That is from a stereoscopic VR, tiled VR. What's going through the decoder? When somebody moves their head. And something similar will happen if you do a mosaic, but I only have a VR example right now. This is somebody moving their headset around, looking around, and you see tiles switching in and out incredibly fast. And this happens within 1 or 2 frames. So it's incredibly responsive. And top left, you will see 2 background images, which is the entire 360 sphere in lower resolution. And we superimpose the high resolution tiles over the viewport. Like I said, this is a VR example, but the thing works exactly the same for multi-view tiled streaming in a flat device. Now, the heart of what we do is the player side. It has the network stack, which is a single network stack. And actually, this is a really good use case for Quick, because there's lots of parallel streams going on here. And because we fully control this stack, we can do this with extremely low latency, like slightly more than a second with tiling, and the player does even below 1 second with end-to-end latency with HLS without mosaic. There's you see there's bitstream rewriting. There is the rendering plugin, which puts all the stuff at the right place on the screen. But the most important and the interesting part is the multi-feed strategy module. This module knows exactly the bandwidth that's available. It knows the objects that are on the screen. It knows the size that are on the screen, so it can determine exactly which feeds need to be retrieved at which quality. And it can implement some very interesting ABR strategies, not just lowering bit rate or resolution. You can also say, okay, my bit rate's not quite enough. Let's not retrieve the thumbnails when they're not visible. Let's degrade the picture-in-picture a little bit while keeping the main view in perfect quality. So there's a lot more options and possibilities for doing ABR. But more importantly, there's no fighting between the different players. You can manage them coherently. And then there's this visibility calculation thing, which is it's surprisingly complicated to calculate the visibility in VR. So, but this is a single decoder stack which can handle VR and mosaic at the same time. So, I think that was the heart I was trying to tell. Why is it no? Okay, sorry about that. So, use cases, multi-camera sports, especially multi-ball sports, which are sports in which there's not the focus on a single ball, but it's like golf, cycling, motor racing, athletics, gymnastics. Multi-game interfaces, NFL day when you have 9 games going on at the same time and you want to be able to follow all of them, switch instantly. But also multi-EPGs. It's great for EPGs when you have meaningless thumbnails or text, and sometimes even wrong. In this case, you can just build an EPG that has what's actually on the channel. And it's also provides some surprisingly interesting applications for doing ad insertion. No longer do you need to do a split and add, and you can just pop up an ad and let it be run by a policy of the provider, the content provider. Coming to my last slide, this is deployed in SkyWorlds, which is an amazing headset sport application where you can view Premier League football and as of tomorrow also cricket. We've tested it last weekend with some 25 feeds in what I would call a typical multi-ball sport to very good user response. I just can't disclose who it is. But it will be rolled out this year in a major way. The challenges is this, because we try to keep everything in frame accurate sync, there's some interesting challenges in what do you do when frames drop, when connections drop? Do you wait? Do you insert something in the meantime? That's an interesting challenge that we're still trying to perfect. And like in SkyWorld's example, we get one 180 feed, a 4K 180 feed directly from a venue. We insert a television feed as a virtual jumbotron, which comes through another path. And then we also have extra 3 to 7 extra HD channels which come through yet another path, and they all have to be kept in perfect sync. We're now working on enabling third-party encoders, which means they're more loosely coupled. So we have to solve a lot of the things that we do in sync, in making perfect sync in the client side rather than in the encoding side. And as I already told, an interesting question is, what do you do with ABR? How do you deal with bandwidth variations? And it's much a user interface question, what do you prefer, as it is a technical question. Thanks very much.